Hello everybody, it's Crazy Logics 007 on YouTube. Crazy Logics in the forums, and everybody else just calls me Damon. We got a Planet Audio 4000 watt AC4000.1D. It's Class D mono. But it worked, gave it to me. He'd already taken the things off. The screws are out of it here. So before we go anywhere else, little back of the napkin here, math. I've already started taking this apart to try to speed things up, but it would have three 40 amp. Oh, let's glare. Let's kind of get a little less glare. 340 amp fuses. Okay, so that's 120 amps. All right. So let's say you're at best probably, most cars 13.5 volts, right? 120 amps, 13.5 volts. We get our little calculator out here so that we can do it. So we take 120 amps times the 13.5 volts, and we get 1620 watts. So that's in a perfect world with no losses in this amp. So let's just say your voltage is a little higher and this thing's super efficient. We're still at probably 1,500 watts. Best case scenario, based on the fuses, it ain't doing 4,000. It ain't going to probably do 4,000 peak. So, on brands like Planet Audio, Boss, some of the others out there, you really got to pay attention to what they're claiming is not RMS numbers. But that doesn't mean they're terrible amps. It just means that they're playing a game where they set the amp, they hit the, fed the amp a lightning bolt and measured the output and said, look, it peaked at 4,000. We'll call it a 4,000 watt amp. And that's just for, consumers that don't really know. They look at this big amp and they think 4,000 watts, that's great. And it does put out a lot of wattage, If anything 1,000 watts and you put it on a couple subs is going to slam no matter what, It may not break SPL records, but it's going to thump. So anyway, I've already started taking some of it apart. I've got the end cap off here, and I'd pulled some other stuff just to speed things up. We do need to stick a fuse in it. All I got's a 30 amp fuse, but we'll need that for troubleshooting if we get it up and going. I've already taken the bottom off and the clamps. And here is the bottom. It does have nice decals showing you how to hook it up, so that's nice because a lot of people lose their structure manuals or just chuck them, and they're up. This is up underneath this cover. You have to take at least one side off and then slide it out if you're going to take one of these apart. So I've removed the clamps, and I can already see, and we'll hold it up here, we have at least a blown power supply. I don't know if you can see the nice dirty nasties that are there, but it's already popped the power supply for certain. We need to check the output section. These are the diodes. So here's the power supply. Power comes in, terminals, goes through the fuses. It's got dual power supplies actually. So 1, 2, 3, 4, 5, 6, 7, 8. So 4 of them are going to be for this one and 4 of them are going to be there. That means this pair and this pair. That's 2 on each pull of that. Here we have, these are labeled U6 and U5. So those are going to be voltage regulators. This right here is your little temperature reading here. I'm trying to get this little foam out of here. Get stuck to there. You got a temperature probe over here. These are all diodes, so you're going to have a set of diodes for this half of the power supply and that. These are the input filter caps, it looks like, because they're right here. It looks like these are going to be the rail caps. These two, we'll have to look at the bottom of the board. They may be with this little set of diodes probably for providing the lower voltage to run these regulators to get your plus and minus 15 for the preamp. Then going to the output, you've got an output inductor, and they do have a fan on it. This is a fan. right there in a little shroud on the output inductor and on the Class D driver board. And this style of Class D driver board has a tendency to overheat a couple of the transistors that help make this all work. So having this fan on here is a really good addition. So while lower, price spec amplifier, they at least have learned on, and this is a common design that's been used in high-end amplifiers, even just, they'll have used maybe beefier board, beefier components, beefier FETs, who knows, whatever. Excuse me. But this design is known that it needs some fan, and a lot of times the output inductors need fan. So they went ahead and had a little fan cage design to help cool not only the output inductor but the driver board. That's really good. These output caps are for filtering. They put two of the negatives together there on each one, it looks like, to make these like a bipolar cap to help on the part of the filter with the inductor there. So good design. It's a tried and true design that has been out for a while. I do not have everything unbolted, but we'll get to that. So we definitely know we got blown power supply for certain, because almost every one of these FETs is charred. And I can see, like I said, I can zoom this in, but you can see the, if I can hold this without dropping it, even the gate resistors right there. The little bitty gate resistors, they're fried and stuff. So what we need to do is we need to look at how this is driven. So we got a TL494 right here, and it looks like these should be the output transistors that are probably driving these two sets. So we'd have should have two sets of them though, unless one set is driving on both this and this, and the other set is driving on both that, and that's very possible. So with the amount of damage with the gate resistors being all blown, we'll probably have to replace these driver transistors, because this drives these transistors to drive these. And then we need to check these output FETs and see if any of them are bad. If we get lucky and none of those are bad and all the damage is here, that's great. But if any of those are shorted, then not only do we have to rebuild the output section, we're going to have to take the driver card out, because there will be a couple of these that, no matter what, have had some undue stress, and we know it's known about a couple, and I'll try to point those out. Also, thank Todd at Ellensburg Amplifier Repair has showed this style of board in one of his videos and talked about it. So if you need more info, you might grab one of his too. I'll try to do as much as I can, but I'm also going to try to shut up and like I said, we'll test these real quick, but then I'm going to play some copyright-free music, hopefully, and get this thing finished, tore apart, and that way you can at least see the components, and I'll try to point out some stuff here and there where I can, but we're going to have to take all this apart and all this, and then I'll talk about a little bit about rebuilding it, and then I'll show you that, and that way you get the pertinent details fast, and the video is not too long, and we talk about the important parts only, and I'll try to blather a little less. How about that? All right, so I'm going to get my screwdriver and get everything prepped on the video here to do a fast forward, get this thing finished taking apart. So it has blown the output, so we're going to also have to take those out and probably take this board out and check it and give it a rebuild and We'll get the outputs out first. We'll see if the drive works, but we need to take a peek in there. But we know we got a whole bunch to rebuild on the power supply. Have to have a functional power supply to see if the drive circuits work anyway. So these will all come out. This will get rebuilt. We'll put one thing you do when you have these have dual transformers is you want to look for this one right here. See, it's got the little extra windings. Right there, where the other one does not. See those little extra shrink wraps and stuff coming down on the edge? This is the one that makes the auxiliary voltages. So really what we want to do is power up this transformer, let it rectify, and that's going to do it. We don't even have to power this one. We can leave this all out while we're first doing it. So a FET here and a FET here after the circuit's rebuilt and repaired and ready. Make sure we got good drive signal. Put the one FET on each one, and that'll get us power up, and that'll get us the auxiliary voltages so we can, after we remove these FETs over here, we can test the drive signals. And that's kind of the way I like to do it, because that means you get the least amount of work, fewest parts in it in case something goes catastrophically wrong. You're only providing the bare minimum needed to power up stuff and start checking the circuits. Unfortunately, you can't do that on cars type thing. You can't disconnect 4 of the cylinders of your V8 to just see if everything's okay. Normally, I mean, technically you can, but you get what I mean. I do need really put some thermal compound there. That was all over the place. Alright, back to disassembling here, and you'll see me get all these pulled, get all those pulled, probably pull the drive resistors, and then figure these out. We'll probably draw them on a little thing, and I'll try to show that to the camera. So, to finish getting this board out, it has a plastic sleeve here and a plastic sleeve here that the main screws went down in the middle to hold the board in place. Well, there's these little screws holding something in over here. There happens to be one here and one here holding this thing in. And I'm going to have to take it out, and I'm going to have to take this end off. But it's real important, because this is kind of bull. This is exactly what I think it is. Let's see, what do I need to take this off? Allen wrenches. Give me a second here to get this end plate off. I know it's not in the camera. And sorry about background noise. I've got the heaters running. It's cold and the dogs flip-flopping around. Okay, so I got that end plate off, and I removed this little clip that's holding something in here. That's going to allow us to slide back out, and now I need to get a hold of this before it makes a disaster. nothing but making me mad. I'm looking down it, trying to make sure I'm not running into anything else. Something's got it hung up. Wonder, can I lift these up? Another screw there in the middle. Wonder if I can flex the board up over it. Yep, okay. So I got the board flexed up over that. And do you see what I see? So this was a little clip with a tab to hold this here in. And this little tab's holding it in. I'm going to back these off a little. It's probably stuck down. You know what that is? This is like flea market type crap, where they've stuck a big piece of steel, they glued it down, to make this heavier. That's all that is. It's just a chunk of steel in the center of that heatsink to make this feel heavy, to make this amp feel heavier. Come on, Planet Audio. Okay, so we got it out and got it a little cleaned up here. Every one of the gate resistors is burnt up, so I'm going to have to pull those. And then we need to see if we can find a little, use an eye loop and a flashlight. A1023s and C1027s. So I always get out my paper. Zoom out here a little bit. And I'm going to make some notes. So those 4 drive transistors. This right here. Set like this. And these are what did I say, A1023. I want to make sure I quote that part right. I don't memorize all these part numbers. The pair techs that do this for a living might. I don't. Yeah, 1023s. That sounds right. 1023. And these are C1027s, I believe. C1027. Is that right? Yeah, 1027. So, if I get this up here, I might be able to see if it'll focus. On that one, you see that big old crack across the front of that C, the Q1P there. So yeah, these things have definitely taken a hit. So in finding out what those are normally, let me zoom in here a little. You notice how I drew them with a D, you know, so they got their legs underneath them here. And this is the flat spot there in front. So normally this is going to be an SA or a KA kind of thing, or an S2. Sorry, not an SA. That's wrong. Or a 2S. Yeah, that's it. 2S. 2S. Sorry, I'm losing my coherent thought. I've had way too much dinner and while my belly's full. It's kind of comical. So let's see if I can pull up a 2SA 1023. So if we pull up Google here, you'll get these transistors and stuff. And we're looking for a data sheet on this thing. So it's a 2SA 1023. We do know all of a sudden it's a PNP, this one says. So up here, this one says PNP. If we look at this one, all transistors data sheet. It's going to tell us it's a PNP. So this is our PNP. Switch back over here. And these are going to be our NPN. But what we're looking for is something that shows us the pin out. And so if we find the pin out, we want a real data sheet. So we just keep going through some of these. Hate sites that try to track you with cookies. What the heck? No, that's not it. What did I click on? That one? Yep. So it's saying from the bottom view, base collector emitter. So that would be base collector emitter. I'm writing that down. And if we look down here, we got some others saying base collector emitter in some of these drawings here. Hey, we may have a... Oh, that's not for it. That's... let's back to it. Telling some of the others, but that's not what we want. A1023, base collector emitter, and that's the flat front. So... these are going to be base collector emitter, and that means these will be two. They're the same. And emitter collector base. I should be able to put the B, D over here and the B, D over here, the 140. And the 139. These are simple numbers. There's some better drivers out there and stuff. I've got a bunch of these, perfect for a cheap amp like this. They're decent enough drivers, and that's what we're going to do. They will handle more wattage. They're less likely to blow than these. And then I'm going to put 3205s in, and I'm going to put 22 ohm gate resistors. So you're going to see me pull all the gate resistors, install new gate resistors, install new transistors here, and then we're going to put a little power to it and check and see if we have good drive all the way across here. If we do, then I'll stick a FET in here and here. Remember, these two run this one, and these two run that one, and we want to run this one, so we're going to stick one here and here. That should bring up the voltages. Then we can check all our drive voltages over here, and our voltages for this card and for the preamp and everything. So then we can see what we got left to fix. Okay, and I said 22 ohm. You can use 22 ohm, but I'm going to put 47 ohm resistors there. So here we go. I'm going to go ahead and add a drop of solder on the top of these because I don't know how quality the vias are that go between the top and the bottom of the board, but I just want to make sure. So I'm going to go ahead and put a little drop of solder on the top of all these to make sure I got good connection from the bottom to the top of the board. Okay, sorry for background noise, but it's cold out here and stuff, so you probably can't see the LEDs over here. I'm going to put my hand and see if they'll light up. We got a protection red over here, and we got a green over here. So let's give it a pulse. It's not pulling too much. See the red on my pinky there? That's the protection. It went out, and I think you can see, yep, the little glow right there, the green. So that means nothing's wrong. And our current draw up here at the top is only 0.2 amps because we're not actually making power. We're just running this little circuit. So we're going to get the scope out. And we're going to go to the pad that is the gate. Oh, looky there. That's a beauty and a bonnie. Let's go. There we go. So there is the drive circuit. And I can zoom in on that for you here. Hang on. So this is what the drive wave should look like. Notice it squares, goes up and down. And so I'm going to go to each pad and make sure we have a drive wave on every one. Now it's got a little ringing at the top. I'll show you what I mean by that in just a second. There we go. So I'm going to get a pointer here. So you see this little jagged up right here. That's a little ringing and stuff. This circuit is unloaded. Meaning it has no FETs in it, so that drive circuit's not having to do anything. So it's going to have a little ring and stuff. So it's going to change. We're going to kill the power. Get these power connections and the remote off. Like I've said before, my remote wire is hooked through a little foot switch. You can get them on Amazon. You can get them through Granger. You can get them just anywhere. You just need a little foot switch that, you know, goes from your power that you've got, your main power, which goes through that foot switch and gives you a remote that you can control with your foot, so that if something starts to go bad, you can let off real quick instead of having to try to flip switches or anything else. You can rig up a flip switch. I would get a 2-position one that has a permanent click in one direction and one that has a spring click in the other, and wire it up to where you temporarily hold the spring click while you're first testing, and then when you know it's good and solid, you could flick it over the other way to solid to, you know, like be doing music tests and checking channels once you're further along. But really with my foot switch, it's not that hard to hold your foot down on it. And then you can rig up an additional jumper wire later when the amp is actually all repaired, and then it'll be all good. So I'm going to grab some FETs count me out 8 of them, but I'm only going to put 2. We're going to put 2 in this center spot right here. And so give me a minute and we'll do that. Alright, we got 3205s. Sorry, didn't have the microphone on. The original FETs or IRFB 3607s. Don't really care. I am going to try these little plastic things that they had on here that are supposedly you can just stick the FET straight into it. You put it in and it sets the height. If I can get in here. So you would solder them all in like that, and then when you bend it over, it's going to be perfect for the clamp. The only problem is a couple of these, and the FET's blue kind of got a little melty, so we will see if they will all work. I'll try to reuse them, but we're only going to do 2. Let's see if that'll hold up. And solder it in, and then we're going to see if we can make some power. I get my old man glasses out here because I've got my light off overhead. When I'm soldering up these legs, I always go one leg and then go back to the other FETs and do another leg. And the reason why I do that is just not to put too much heat into any FET or any terminal. I try to either that or take kind of a pause in between. Just whatever you can do to reduce the heat soak sometimes into the FET. Now this leg here needs a little extra there to fill that all in. There we go. Alright. So we got our FETs. I'm going ahead, hook up the remote. So ground was over here. Power there. Turn on the power supply. It should jump up to about 1.9-ish or so for my thing. So now watch the current up over here. The current's the one on the bottom, the one in red. We're going to pulse this thing because we don't want it going too high. You see it shoot way up, and it's settled down at 1.4 amps, 1.3 amps, which means it's drawing about 1.2, and the green light already came on. So we'll let it set for a second. Red light comes on first, gets stable, green light comes on. So that should mean we should see, I'll switch it to AC here, so we should be able to see the square wave there, centered up on those. All right. So now what we need to do is put our multimeter on DC volts. We should be able to go. So these will have a center tap, but right now we're just going to want to go the middle leg of each one of these rectifiers, but we're actually going to go on the back so we can see the rail voltage. So right now you can see it's at 8, and I'm watching for the green light. Green light's on, so we got 135 volts rail to rail. And now if I go down here and catch this middle terminal, should be able to show you 67.2, and it should be negative 60 something. So 65.6. That's pretty good. We all can also use that point as a reference on our op amps. Here should have like about 15 volts. That's coming out of one regulator, and we should have negative 15 or 15 there, negative 15 there. That means these two regulators are working. This is, by the way, is loose. I think we broke some grounds on it. Looks like it. We will have to give that an inspection. I forgot to unsolder it to check it. Now I got to go find my reference sheet so I can check some voltages for that. But we're still powered up. Technically, that does not look like a good drive. On the low side. Looks like we got all kinds of noise, but this low side, if I turn my reference here and go back to DC, I'm on 10 times. Switch it back to AC. Yeah, we're not seeing the appropriate drive. I got to double check and make sure. We may have to inject a signal to see a good drive, but probably not good here. I'll have to see what voltages we can get. The other thing, I got this thing on, and I noticed my fan no spinny. So this little fan, I don't know if it's temperature controlled. It may be temperature controlled, I don't know. I would have thought they would have had that sucker running constantly. That's what I would have done. So that fan circuit may be bad too. So, all right, let me get my other stuff together and we'll start investigating this. But we appear to be making. Whoa! I didn't notice that. That's a goofy looking little thing with some dirt on it. Let me turn off the power so I can. Up the lamp here. See that right there? That opto amp, it's kind of jumped up. Right there, UP or U4P. It's got some debris there. I don't know what's up with that. We'll have to inspect that too. But hey, we got functional power supply. We're building rail voltage. We got our plus or minus voltage here. We just need to check any auxiliary voltages on this board. Like I said, got to get my notes out. I don't memorize them. This board happens to, let me see if I can slide this stuff out of the way. Actually happens to, can you see in there? If you look right there, you can see it says negative 15 plus 15. It starts out as in, so that's going to be the audio in. You're going to have all those other things going down and the outputs and all that. So, you know, that's what we're going to be looking at. We're going to be testing it on the back here. So the other thing I want to check real quick is we've been unhooked with power. So it does have pull down resistors. This looks to be the pair of pull down resistors for the rail caps right here, which is great when working on these. That way I don't accidentally hit 135 volts into my fingers or into something else. So that's fantastic. And then I'll going to desolder this. I'm going to do this first because if I have to inject a signal to see the drive, then we'll have to have this fixed. So this is going to get desoldered real quick, and I'll be right back. I've got videos of taking these out and repairing them. Even if the legs are broke, you can solder in, wrap a little new wire in there, solder it in, and redo it. So check out some of my other videos if you need to see how to fix one of those yourself if you get one that's broke. But I'm just going to desolder this one. We'll be right back. Oh yeah, she was good and broke. She broke this leg and both the front ground pins. There, see that broke off here and there. I broke that back leg. I'll see what all I got to fix this back up, and then I'll get it back in, and that way we can move forward. Okay, so I repaired the RCAs so we could feed a signal in. So we're going to check a few things on this driver card. You always got to rebuild these almost 99.9% of the time. I did check the output FETs. They're up here, ones we'd taken out, and I took them out in order. This FET and that FET had blown. So that's one on the high side and one on the low side. So most likely have damage to the drive circuit. But we're going to start, you can see up there the scope right there. I am feeding into the RCAs a 50 hertz signal, and we're going to look at pin 1. And pin 1, if you remember when I showed you, said that it was the input. And so we're going to power this up. We're going to look for the green light. Green light came on. And we're going to read pin 1. And my voltage is way too high, but I'm feeding it a 50 hertz signal. And there you can see it. And so it's getting it. Now we can change it to a 60 hertz signal, and it's going to be a little different. Triggering on here, and there you can see it. So we're getting signal through the preamp section and everything else. I'm going to kill the power. So we're going to take that off. And we're going to check the couple other pins on the driver board. Now that we've got this out, we're going to look for low side drive. If I can find my little layout here where it tells me pins in order so I don't lie to you. Okay, so pin 1 was the output. We're going to switch the scope. Times 10, and we're going to go DC. So we're going to power up here. Oh, I got to power up. So pin 4 should be the positive 15 volts. 2, 3, 4. Oh, and I got it on times 10. Hang on. Let's put that on times 1 right now to measure this. That should be the 15 volts. And pin 5 should be the negative. So we see those jump up and down. And we can also verify that with our meter. If you put your probe on the center ground there and very carefully, 1, 2, 3, 4, I should have 15 volts, I do, and 5, I should have negative 15. So the very last pin, pin 17, should be the negative rail, negative 68.3, is that what we got here? 68.3. And then the 1, 2, 3, 4, 5, 6, the 6th pin, VPP, is actually higher than the positive rail. So this one by about 15 volts. So we're at 68, so we need to be at 70. about 82 or so. On pin 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So yeah, we're about 14 volts higher, and that's to drive the high side fits. But if we go now and we go look at the gate, we can switch it to AC to try to get a better thing. Look at the gate drive. I don't know if you can even see it. Where's my intensity? See how that looks? That is not a good gate drive on the low side. So we definitely have to take this out. So while I do that, I'm going to remove this, and I'm also going to take this fan out. I did see, and I'll point it out to you when I get to it, that there is a little thermistor on the side here. When we get this off, you'll be able to see it. But I can see it down in there that's on there, and I want to put a little dab of thermal paste on there. But for this inductor, that turns that fan on. If it was me, this thing would be running all the time, but I'm going to lube this fan to help cool the circuit board. This design is inherently hot running and can tear up the boards over time due to just baking the board. So, alrighty, we'll get to taking that apart. So you got your little fan in here and stuff, and you will see that on the back, if I can find, there it is, there's normally a decal. Now I did test this fan because in trying to figure out where it was getting drive, or whether it was any good, because it wasn't running when we first fired up the amp. But you pull the little sticker. See, I pulled the little sticker back. You can get back here to this bearing. And if I can find my 3-in-1 oil, I'll put a drop of 3-in-1 oil on it. I'm not sure where it's at. I gotta, oh, there it is. Right where I put it. So, just a little oil. Oh my goodness. Cap doesn't want to come off. So, just the tiniest of drops. It's not wanting the tiniest drop. So if you get a big can of 3-in-1 oil, a couple ways you can do it. You can get you a Q-tip, cut it off at an angle, like so. Put you some oil on it, and dab it down in there. You can just keep getting a little bit of oil until you finally get it oiled up. I've got a drop on there. Get it in there. Kind of work it around. We're just going to get down into that bearing. Spin that little fan around a little bit. And just put that sticker back down. That sticker should be a good dust cover. Then we're just going to work that fan back and forth a little. There we go. That ought to lube that fan up. And this is that little thermal sensor right there. So I'm going to put the caps back on this stuff because we don't want to make a mess. You can see it's labeled TH2, and it's the little green thermal sensor there. I want to a little dab of thermal paste on there before I put this fan back on. So when I go to reassemble all that, I'll do that. But we got a board to work on, a driver board. Here is our driver board. And this driver board is labeled different than all the others. Just because it was made for Planet Audio. I do notice one thing they did on this one. This is a 10K resistor, and it's normally a small one, and it'll burn up. And they put a big, nice quarter watt. Oh, my soldering iron. Resistor there. So they have started improving this. There's a couple of these transistors that we need to replace. I wish they had put these bigger C1027s in their place, but they don't. And so we'll let me get a little more room here and get zoomed in on this so we can do it. I kind of want to just at least scan by real careful on this and all the board numbers like that. I have to move my glasses so I can see the screen. Let me get the scope off there. But I want to get a good thing so that when I say a number, somebody can compare it to what it is, because I'm going to be saying the numbers that are on this board, but they correspond to different numbers on different manufacturers, even though the boards look the same. You know, they may be on a red board. This has got some of that dirty stuff. I think they did some white paint marker stuff, and I think the same on that little opto isolator that I thought looked suspicious. I think it was just crappy quality control, because I see this chip's a little sideways and stuff, so I don't think it was affecting the performance. This amp, the guy at work, when he gave it to me, he knew he blew it up because his truck had caught on fire when it was playing for another reason or whatever, and so everything went haywire in his truck, and so he had to deal with all that, and now just trying to fix up the amp so he can get his tunes back as he's fixing everything back up. So, all right, I'll be right back. We'll get ready for this, and I'll get some parts out here. We'll see if I can do a goober's job of explaining this. Okay, to start disassembling this, I'm just using my wide tip on my soldering iron. You go to I've went through and kind of pushed up all the little legs on the transistors, and then you just add some solder across all three legs real good. Run your soldering iron kind of back and forth, bang the board, and if you've straightened out the legs, they'll drop right out. And so that's what I'm doing with all these, and I will show you which ones were taken out. And I got a little drawing here. I just need to add all the resistor values up. Once I get the transistors out of the way, I wrote those all down. I will write down the resistors, and then we're going to check those too. But I'll show you my little drawing. It's over here. But I'm going to finish doing this, and then we'll flip it over, and I'll show you a couple other things. Okay. So I desoldered all the transistors out. I did the resistors. I'm going to pull this up. Let's see. So there is the transistors. Let's see if I can get a pointer here. So it's an A92, 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 a C1027, 27, and an A1023 here. Then it goes to a C1027 there. This is an MPSA 56, 56. Then it goes to the A42s, then 56s again, and A42s. And then these are the resistors. So each resistor is beside this transistor. You got 47K, 100 ohm, 100 ohm, 1200 ohm, 1200 ohm, 150 ohm, 1K, 1200, 10, 10, 10, 220, 560, 560, and 10K, just in case somebody can't read my handwriting. Now, I'd already replaced these two, and I want to show you why. This is exactly as this board's laid out. That's all those in a row up to these capacitors here. Now, something you normally replace on these is the resistor that's here, but this one's got a big monster resistor. Instead of putting a little tiny resistor that gets burnt up, they got a big monster in it. Checked out fine, and so I think they figured out that, you know, some of these boards really bad suffer from heat damage right here where these two are specifically, and that's part of the reason why I put them in here, so that they stand out to you. So these two here, the heat damage spreads. These four, where there'd be two right here in this spot, I think that's the low side drive. It might be the high side, and then the other side is the high side drive. It's one or the other. These are some of the drivers that drive these, so that's why I replaced these. I do not have in stock the C1027s and the A1023. So hopefully these are good. I'm going to test them with a multimeter in a minute. But there's a whole reason why I wanted to show these others also, besides pointing out that this is the area where heat damage happens to the board, and it can slowly cook the board and make it conductive. So you kind of need to be probing around and testing and inspecting. Now this board, because the amp blew because of other reasons, may not have been running long enough to have done any heat damage. You know, they may have done a little bit of figuring and maybe increased the trace size a little or something, because they did this modification already. But the whole point in showing you this, I mounted these two transistors, and you notice they're up from where the other ones were. And what I did is down here on the board, this is a trick that's in Perry's guide. He actually used to be able to get transistors that were the bigger package size, like these. You could get these in the bigger package size, so they'd help dissipate some heat, and he shows some ways to help mount it and get a fan on it. But what I did is I stuck the transistors in the hole, stuck this back in place, and pulled them out, pushed them out as tall as I could get them, as close to the fan as I could. And so I've set my heights now. I've soldered these in, and that's what I'm going to set all these replacement transistors to, so they're all a bit closer to the fan right there, and they get a bit more cooling air. Plus the longer legs is a little more metal. That gives it a little more cooling, just hopefully to increase the reliability of this. So there you've seen over here what goes where. This is all the old ones. I don't trust them. You know, we had stuff blow, and then I'm going to go on ahead and put these in, and then the A92s, I've also got that here. They're all MPS A92s, MPS A56s, and MPS A42s are the ones that we're going to be replacing. And like I said, they were right there on the little diagram. So if you need to know, but this is the way I would rebuild this card. I would love to replace these also, just because the two of these are one of them's a switch thing is how it's described. Two of them are matched pair that are a constant current source with this one as a constant current source, I believe. But this is the differential amplifier. That's what that's called when you do them up. I could show you maybe a picture of a differential amplifier from a Rockford with a constant current source, because I think I got a schematic like that, just so you understand it. Let's see here. See if I can pull something up here real quick. Yeah. So let's go to the left screen. So there is a differential amplifier that's got a matched pair of 88s with a 3904 down here, is acting as part of the constant current source, and that's where the signal is going to feed in this on these. Now there's another pair of these that are up here in the A92s that help drive, I think it is, the high and low side. So you got to remember that this board is basically using transistors for everything that a lot of the more modern boards now are using a chip for. So you're basically building that chip kind of right here. So the chips make it easy because they have all this stuff built in and they do all that stuff for you. So I'm going to go ahead and put this all back together. I will get it stuck in, and then we will pull this over here, get it hooked up, and I'll show you the results of it. And I'm not going to bore you with the the fast forwarding, because I already got some of that in this video, I think, and I may cut some of it out. Trying to make the videos short. I like watching videos with the fast forward just because I like seeing everything they do, even if they have it in really fast forward, because YouTube does allow you to slow it down if you need to see them kind of doing something. Maybe you need to, if we were zoomed in on the board and I was doing something, and that might give you a part designation or something that you wanted to see or something like that. So I like having that included in personally on YouTube videos. Not sure that everybody else does, based on what I would look at my analytics, and people only watch about 8 minutes of a 40-minute video, and so I think they're just jumping through and wanting to skip over it. They may not like the fast forwarding, so it's probably a preference thing. I'll try to include some things where I show some work so you can see screws coming out of certain places, so that you do know what screws go back in. I always find that helpful, like on game consoles and stuff too. But anyway, I'll get that work done here real quick, and then we'll put it back. I'll get it put back in, and then we'll fire everything up. Okay, the board is in. I've installed 2 new outfit fits. Every time I've ever worked on one of these boards, I've never been able to get it to give me, I don't know if it's even supposed to, give me a square, like a low side square wave without having FETs in. So I got 1 in each. They're sacrificial. I've got a bin full of the IRFB 31N20s here. And so I go with, cross my fingers that I did it right. That's why I rebuild everything pretty much on this card, just in case there's a leaky transistor. Like I said, just in case. We are going to, I got my probe on 10X. We can turn it down to 1X, I think. I got my scope on AC. So let's put my finger here by the thing. We'll power it up. Pulling some amperage. Green light is on. Let's check the low side gate. Hey, looky there, we got a pulse train. And so if I switch this to 10 times and put it to DC, we should see, well, you probably can't hardly see it there. Maybe if I turn and adjust the trigger. There we go. So now you can see it riding down on the low voltage side. Let's see if we can see the high side. There's the high side pulse train. Let's make that a little bigger so you can see it. So it appears to be working. So we're going to gently touch the FETs. So the low side's nice and cold and the high side's a little warm. And that is supposed to be common for these style. Is the high side, I think it is, runs a little bit warm outside of the heatsink, especially since I only got 1 in. And so, kind of a weird Class D. It was one of the earlier designs, not my favorite by any stretch of the imagination. I really wouldn't actually be fixing this one normally if it hadn't been that my buddy insisted, and he really just wanted this amp back up and working. So I'm going to kill the power. I'm going to install the rest of the power supply FETs and the rest of the output FETs, get it back in the heatsink so that we can try a little audio test. And then I think we're done. I hope I didn't throw you off too bad on learning a little bit about this old style drive. I don't know how old this amp technically is. I think there's more modern ones that are still using some of this design, maybe slightly modified, I don't know. But really modern stuff is, got the chips, and I mean, now we got the full bridge designs coming from everywhere. So okay, let me get all that stuff installed and I'll be right back. All right, Got my scope out. You can see the scope up there. Amplifier's up. Got the radio playing. You can hear it. Lights up Anarchy there on this display. You can see there on the scope. See what it's playing. Pretty good. She works. Time for a burn in. I'll have to get some screws to be able to hook up bigger power wire. But she is functional. Alrighty. Well, as always, thanks for watching. Like, subscribe, all that YouTube hoo-ha. Try to get some more videos out. I got a whole bunch under development that are all real close to done that are important to me to get out and be kind of right. But I wanted to get this amp done real quick for my buddy so he could get tunes back in. He's been pretty bummed. So take care of him. This one's working. Like I said, I'll give it a big test of my load and stuff, and we'll get her good and hot, and then it should go back to him. Hope you learned a little something. If nothing else, if you're watching and stuff, support right to repair legislation for everything, for all kinds of consumer electronics, tractors, everything. It's a really big issue right now, and I just want to say that. And thanks for watching, and be safe.